How does a structural engineer decide whether to use an I-shaped beam, a joist, or a truss in a steel system? There are three main horizontal members we can use in a floor system: I-shaped beams, joists, and trusses. But when do we choose one over the other? That's exactly what we'll dive into in this video. Before we get started, here are two key factors to consider. Strength. The member's load capacity ratio must be less than 1. Deflection. The member must meet a deflection limit of L240 to ensure stability. Now let's break it down. There are three main factors that influence our choice: span, loading, and aesthetics. Sometimes architects prefer exposed trusses for design purposes. Let's say you have a 50-foot by 50-foot steel bay at the roof level with a snow load of 22 pounds per square foot and a live load of 20 pounds per square foot. In this case, a simple I-shaped beam works great. The loading is relatively small, and deflection isn't a major issue. But what if we increase the span to 60 feet? Now we need a stiffer member. Since it's mainly a deflection issue, a joist would be a better choice. Now let's say we decide to add a few floors above the roof. The loading increases significantly, so now we need something much stiffer. This is where a truss comes in. A truss saves a ton of material and can be customized to fit our needs. But what if the owner insists on using I-shaped beams, even when loading conditions are extreme? How would you tackle this challenge? Drop your thoughts in the comments below. When analyzing a truss using the method of joints, if you find that the forces in the members don't align, for example, if the internal force in member BE is 0 when applying the equilibrium equations at joint B, but when applying equilibrium at joint E, the force in member CE has a value of cosine of phi times F sub CE, stop immediately. This signals that the structure is defective. You might wonder why the equilibrium equations aren't compatible. Understanding this often comes with years of experience in structural engineering. But thanks to Chebyshev's criterion, there's a simple way to determine if a structure is stable or not. Here's the formula. I is equal to 2 times the number of joints minus the number of members minus the number of constraints. If the result, I, is less than 0, the structure is unacceptable. Even if I equals 0, that doesn't necessarily mean the structure is stable. To be sure, we check the degrees of freedom. Let's break it down with the truss shown, which has 7 joints, 8 members, and 4 constraints, each hinge providing X and Y restraints, adding up to 2 constraints per hinge. When applying the formula, the result indicates that the structure is not acceptable. To fix this, you can add a member between joint A and E, or between joint B and D. This simple adjustment can make the structure stable and acceptable.